Hello everyone, I am Dr. Pranita Palve, Assistant Professor in Civil Engineering Department of MVP Samaj's KBT College of Engineering, Nashik. In a previous sessions, we have studied the basics of the fluid statics, Pascal's law, hydrostatics law, and pressure variation when the fluid is at rest condition. Now in today's sessions, we are going to study the different pressure measuring devices. When the fluid is at rest condition, it is subjected with the fluid pressure, and this pressure of the fluid is measured by the two different ways. One is the absolute pressure and second one is nothing but the gauge pressure. The absolute pressure is nothing but the pressure which is measured above the absolute zero or complete vacuum, that is called as the absolute pressure, and the pressure is measured above the atmospheric pressure or with reference to the atmospheric pressure, then that pressure measuring system is called as the gauge pressure. Now first we will see the diagram. In the diagram, that x-axis represents the absolute zero pressure and y-axis shows the pressure. Now absolute zero pressure means there is a vacuum, that means zero pressure is available. So whatever the pressure which we are measuring with respect to absolute zero pressure, that is called as the absolute pressure. The second is nothing but the gauge pressure. The gauge pressure which measures with the help of the pressure measuring instrument. That means that instruments are designed with reference to the atmospheric pressure, and therefore we can say that the pressure which we can measure with reference to the atmospheric pressure, we call it as a gauge pressure. Then third term is nothing but the vacuum pressure. That vacuum pressure is nothing but the negative pressure, and that pressure is always below the atmospheric pressure. So this is the pressure measuring system. The next term is the measurement of the pressure. Generally in day-to-day life we are measuring the pressure by some device. Okay, that is nothing but we can measure the pressure with respect to the atmospheric pressure. So whatever the pressure which we are obtaining the value of some pressure, that is nothing but our gauge pressure. First example is we are measuring the blood pressure. So blood pressure we can measure with the help of the sphygmomanometer. So that is the device which measures the blood pressure. Secondly, in at the garage we are measuring the air pressure of inside the tires, so that we can measure by some dial gauges. So these are the devices which measures the gauge pressure with some devices. So therefore here also we can classify the devices based upon its use, whatever the material which we are using, that is nothing but the manometers and the mechanical gauges. Basically manometers are nothing but the these are the small tubes are there, okay, and it is based on the principle of hydrostatic balance principle. Okay, it is used for measuring the pressure at a particular point in the fluid by balancing the column of the fluid by some another column of the fluid. So pressure can be measured at a particular point, or we can measure the difference between the pressure at two different points of the same pipe or two different points of the two different pipes. So again these manometers are classified as the simple manometers and the differential manometers. Now what is meant by simple manometers and differential manometers, we can see in the detail in the next session. Next is the mechanical gauges. That mechanical gauges measures the pressure by balancing the fluid column by the spring or the dead weight. So commonly used mechanical pressure gauges are diaphragm pressure gauge, second is the Bourdon tube pressure gauge, third dead weight pressure gauge, and fourth one is nothing but the Bellows pressure gauge. Now we will see first what is meant by simple manometers. It consists of a glass tube having one end connected to the point whose pressure is to be measured and other end remains open to the atmosphere. In simple manometers, piezometer is one of the simplest form of the pressure measuring device. So generally it is in the diagram we can see that A is the pipe, and at particular A point we are measuring the pressure. So therefore this piezometer is connected at A point and other end of the pipe is kept open to the atmosphere. So whatever the rise of liquid level in the vertical column is there, so that we can measure in terms of pressure head. So this pressure head we can use to determine the pressure at a particular A point, and here we can determine the pressure at A point as rho GH as per the hydrostatic law. Here rho is the mass density of the fluid inside the pipe, G is the acceleration due to gravity, and H is nothing but the pressure head. And the pressure at A point we can measure in terms of Newton per meter square. Second type of the simple manometer is the U-tube manometer. This U-tube manometer consists of the glass tube bent in U shape, in which the one end of the tube is connected to the point whose pressure is to be measured, and other end of the tube is kept open to the atmosphere. Now with this U-tube manometer we can measure the gauge pressure as well as the vacuum pressure. So let us consider the first case is for the gauge pressure. Now consider this first diagram. Now in this first diagram, that B is the point whose pressure is to be measured. Now let us consider the datum line AA. Now above that datum line, because below this bottom line the same liquid is there, and therefore here equilibrium condition can be achieved, and therefore we are considering the upper portion of this datum line. Let H1 is the height of the light liquid above the datum line, and H2 is the height of the liquid above the datum line. Now in case of the U-tube manometer, the manometric fluid is used. Generally the manometric fluid used as a mercury in case of the U-tube manometer. Then S1 is nothing but the specific gravity of the lighter liquid which is flowing from the pipe. S2 is the specific gravity of the heavier liquid inside the U-tube manometer. Then ρ1 and ρ2, these are the densities of the heavy liquid that we can determine from the specific gravity. Now pressure is same for the horizontal surface, and therefore pressure above this horizontal datum line AA in the left column and in the right column should be same. So therefore we are considering separately the pressure in the left limb as well as into the right limb. Now consider first left limb of the first diagram. Now in the left limb above the datum line we can determine the pressure, that is pressure at B point plus ρ1gH1. ρ1gH1 is the pressure of the left liquid which is inside the left limb. Then pressure above the AA line in the right limb can be given as ρ2gH2. So these are the two pressures at left limb and the right limb. Now we have to determine the pressure at B point. So therefore for the equilibrium condition above the AA line, pressure in the left limb and right limb is same. So therefore we are equating the pressures of left limb as well as into the right limb. So therefore we can obtain that pressure at B point is equals to ρ2gH2 minus ρ1gH1. So this is the formula. By that way we can determine the gauge pressure at particular B point inside the tube. Now second pressure is nothing but it is a vacuum pressure. For measuring the vacuum pressure, the level of the heavy liquid in the manometer is shown in this diagram. See this second diagram. Now this dark color is nothing but it is a heavier liquid. So for the same like your previous case, we can determine the pressure of the B point by considering the datum line AA. So pressure into the left limb is equals to pressure at B point plus ρ1gH1 plus ρ2gH2, and therefore if we what is the pressure in the right limb? No liquid level is there above the datum line, so therefore pressure in the right limb will be 0. So now we are calculating the pressure at B point, which is equals to, by arranging that term, it is a minus ρ2gH2 plus ρ1gH1 with the minus sign. So therefore this equation indicates that negative sign means it is a vacuum pressure. Next type of the simple manometer is the single column manometer. It is the modified form of the U-tube manometer, in which reservoir having the large cross section area, and it is about the 100 times the area of the tube, is connected to the one of the limb, and that limb we measures the change in pressure level. Here the cross sectional area of the reservoir is very large. For any variation into the pressure, the change in liquid level into the reservoir will be very small, which may be neglected, and therefore the pressure is given by the height of the liquid in the other limb. So for here the two cases are considered, the vertical single column manometer and the inclined single column manometer. First case is vertical single column manometer. See the diagram. In the diagram, XX is the datum line in the reservoir as well as into the right limb of the manometer when it is not connected to the pipe. But when manometer is connected to the pipe, due to the heavy pressure at A point, the heavy liquid in the reservoir will get pushed in the downward direction, and due to this pushing of the liquid in the left limb, there is a rise of liquid into the right limb. For delta H is the fall of heavy liquid in the reservoir. H2 is the rise of heavy liquid in the right limb, and H1 is the height of center of the pipe above the XX datum. PA is the pressure at A point which is to be measured. Capital A is the cross-sectional area of the reservoir. Small a is the cross-sectional area of the right limb. S1 and S2, these are the specific gravity of the liquid inside the pipe as well as in the reservoir. Rho 1, similarly rho 1 and rho 2, these are the mass densities of the liquid in the pipe and the reservoir respectively. Now fall of heavy liquid in the reservoir will be equals to the rise of liquid into the right limb. So therefore the volume of the volume of the reservoir and volume of the fall of liquid into the reservoir and volume of the rise of liquid into the right limb will be same. So therefore capital A into delta H is equals to small a into H2. Now the new datum line is considered as a YY, and with respect to that Y we can write the equation for the pressure in the left limb and the right limb. So pressure in the right limb is equals to rho 2G H2 plus delta H, because we are considering datum line as YY, and similarly pressure in the left limb is equals to rho 1G delta H plus H1 plus pressure at A point. So equating these two pressure for the equilibrium, we are obtaining pressure at A is equals to H2 rho G rho 2G minus H1 rho 1G, and by that way we can determine the pressure at A point in the single column manometer. Instead of vertical single column manometer, if it is an inclined single column manometer, then the vertical right limb get replaced with the inclined limb. Now this right inclined limb is making an inclination of theta degree with the horizontal. So therefore here we can consider the triangle, and with that geometry we can write instead of H2 is equals to L into sine of theta. So therefore pressure at A point we can determine from the formula L sine theta into rho 2G minus H1 rho 1 into G. Second type of the manometer is the differential meter. It is used to measure the pressure difference of pressure between the 2 points in a pipe or of the two different points. This differential manometer consists of U-tube containing the heavier liquid whose two ends are connected to the point whose difference of pressure is to be measured. So first type is nothing but the U-tube differential manometer. See the diagram. In the diagram A and B, these are the 2 points whose pressure difference is to be measured. It contains the heavier liquid in the U part. So here XX is considered as a datum line. Above that datum line we are considering the pressure for the consideration. With the hydrostatic law we can determine we can write the equation for the left limb and the right limb. Pressure in the left limb we can obtain, it is a rho 1G into H plus X into plus PA. Similarly pressure into the right limb can be measured above the datum line XX as PB plus rho 2GY plus rho G into H, where rho G is the mass density of the heavier liquid. So generally heavier liquid is considered as a mercury. So for equilibrium we are considering the XX line as a datum, and above that we can equating the pressures of the left limb as well as into the right limb. So we can obtain the relation between the PA minus PB as G rho G minus rho 1 plus rho 2GY minus rho 1GX. If the point A and B are at the same level, then we can obtain the pressure difference PA minus PB is equals to GH in bracket rho G minus rho 1. Second type is a inverted U differential manometer. Generally these are used to measure the low pressure, and the liquid, manometric liquid, is lighter than the liquid which is flowing from the pipe. So therefore here the terminologies are same, only rho s is nothing but the density of the light liquid. We can write the equation for the left limb and right line below the x-axis line. So Pa minus Pb is equals to rho 1g h1 minus rho 2g h2 minus rho s g h. Thank you for watching the video.